Is time travel possible? Short answer, yes. Time travel, a concept that has captivated the minds of countless science fiction enthusiasts. A concept so rich in its allure that it has spurred the creation of over 400 works of fiction, as listed on Wikipedia. This concept often paints vivid pictures of characters harnessing some method or device to journey across the continuum of time, either venturing back into the forgotten past or catapulting forward into the uncharted future. A concept that has been the cornerstone of numerous novels, films, and television shows, sparking the imagination of millions across the globe. But let's pause for a moment and ask ourselves, what exactly is time travel as defined by science? How does science interpret this concept that has been so glamorously portrayed in works of fiction? And more importantly, is it really feasible? The renowned physicist Stephen Hawking once stated in his book Black Holes and Baby Universes that the best evidence we have that time travel is not possible is that we have not been invaded by hordes of tourists from the future. But while Hawking may have dismissed the possibility of humans ever developing the ability to time travel, science has a slightly different take on this. Consider Albert Einstein's theory of special relativity, which proposes that time is not a constant, but rather it is relative to the observer. This theory suggests that an observer moving at the speed of light would experience time at a much slower pace than an observer who is stationary. This is why astronauts in space age slower than their counterparts on Earth. The twin astronauts Scott and Mark Kelly demonstrated this when Scott spent a year on the International Space Station while Mark stayed on Earth. Upon Scott's return, it was found that he had aged slower than Mark. It wasn't a dramatic difference, but it was a difference nonetheless. So in a way, time travel is possible, but it's not quite the same as the time travel we often see in science fiction. There's no DeLorean or TARDIS involved, but who knows what the future holds? Physics king Stephen Hawking once pointed out that the best evidence we have for time travel is that it cannot and will never happen. A bold statement from one of the most brilliant minds in recent history. Hawking's skepticism was grounded in a simple observation. We haven't been invaded by visitors from the future. Hawking's reasoning is simple yet profound. If time travel were possible, wouldn't we already have evidence of it? Wouldn't we see tourists from the future or receive messages sent back in time? Yet we see none of this. No future civilization has come knocking at our door. No time-traveling emissaries have appeared with warnings or wisdom from beyond our present moment. Hawking's argument is a form of what philosophers call a reductio ad absurdum, a method of refutation that involves taking a proposition to its most absurd conclusion. If time travel were possible, we'd already have undeniable evidence of it. But since we don't, Hawking concluded, the most logical assumption is that time travel is impossible. Yet science is never that simple. While Hawking's argument is compelling, it isn't definitive. It's based on our current understanding of the universe and our current technological capabilities. Science is always evolving, always growing. New discoveries and technological breakthroughs could change our understanding of time and space in ways we can't even imagine. In fact, from another perspective, the concept of time isn't as rigid as we might think. The theory of relativity, proposed by another great physicist, Albert Einstein, suggests that time is flexible, that it can be stretched and squeezed, that it can flow at different rates in different places. In other words, time is not absolute but relative. This is what we call time dilation, a phenomenon that has been confirmed by experiments. So while Stephen Hawking may have been skeptical about the possibility of time travel as we commonly understand it, he wasn't opposed to the idea that time is flexible, that it can be manipulated in certain ways. He was open to the idea that there might be more to the story, more to the universe than we currently understand. But from another angle, science also supports time bending. Physicist Albert Einstein's theory of special relativity proposes that time is an illusion and that it moves relative to the observer. Now, let's unpack this statement a bit. According to Einstein, time is not a constant but a variable that can change depending on the speed of the observer. This idea is a radical departure from our everyday understanding of time as a fixed and unchanging entity. In the theory of special relativity, Einstein introduces the concept of time dilation. This is the idea that time slows down for an object that's moving at high speeds. To illustrate this, imagine two clocks. One is stationary and the other is moving at close to the speed of light. If you could observe both clocks, you would notice that the clock moving at high speed is ticking slower than the stationary clock. This is not a mere theoretical prediction. It has been tested and confirmed in numerous experiments. For instance, scientists have used highly accurate atomic clocks, one stationary on Earth and another on a fast-moving airplane. The results? The clock on the airplane, moving at high speeds, indeed ticked slower than its stationary counterpart. Now, what does this have to do with time travel? Well, if time can be stretched and compressed, it implies that it's possible to leap forward in time. That is, if you could travel at the speed of light, you could theoretically reach the future faster than those who remained stationary. This brings us to a fascinating real-world example. Astronauts in space who are moving at high speeds relative to us on Earth experience time slightly slower. This effect, although minuscule, has been confirmed using precise atomic clocks on the International Space Station. This is also the reason why some astronauts age more slowly than someone the same age on Earth. So, while time travel as depicted in science fiction, with its dramatic leaps into the past or future, remains a fantasy, Einstein's theory of special relativity shows us that time is far from absolute. It's flexible, relative, and yes, open to a form of travel. Twin brothers Scott and Mark Kelly stand as living proof of a fascinating scientific concept. Their lives, though parallel in many ways, diverged in one significant aspect. Scott spent nearly a year aboard the International Space Station, hurtling through space at immense speeds, while Mark remained grounded, carrying out his duties here on Earth. In the grand scheme of things, what difference does it make? Quite a significant one, according to the theory of relativity. Einstein's theory postulates that time is relative to the observer, essentially meaning that time can flow at different rates, depending on one's velocity and proximity to a gravitational field. This phenomenon is known as time dilation. Imagine two clocks, one on a spaceship traveling at near light speed and the other stationary on Earth. The clock on the spaceship would tick slower than its earthbound counterpart. This is not a mechanical defect or an illusion, but a fundamental aspect of the nature of time itself. Returning to the Kelly twins, when Scott returned from his year-long journey in space, he was technically younger than his twin brother Mark, albeit by a fraction of a second. The high-speed travel and reduced gravity experienced by Scott meant that he aged slower relative to Mark. This real-world example aptly demonstrates the effects of time dilation. Now, one might ask, how does this relate to time travel? Well, if one were to travel at speeds approaching the speed of light or near a massive object like a black hole, time would slow down significantly for them relative to an observer on Earth. If they were to return to Earth after their journey, they would find that more time has passed on Earth than for them. In essence, they would have traveled into the future. So it can be said that time travel is completely possible. However, this concept is not the same as the genre we often hear in science fiction novels or movies. It's not about hopping into a time machine and popping out in a different era. It's a subtler, more profound concept, deeply rooted in the fundamental laws of the universe. Can black holes take us back in time? According to NASA, Albert Einstein's general theory of relativity can offer scenarios that allow tourists to go back in time. This is exactly what happens inside black holes, where time doesn't always move forward. But don't pack your suitcase just yet. Traversing the event horizon of a black hole is not for the faint of heart. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape their pull. They are the ultimate roach motels of the universe. Everything checks in, but nothing checks out. Now, this extreme gravity can do some pretty weird things to time and space. According to Einstein's theory, the closer an object comes to a black hole, the slower time moves for it. This is not some abstract concept, but a measurable effect known as time dilation. But what about going back in time? Well, that's where things get even weirder. Some scientists have hypothesized that inside a black hole, beneath the event horizon, time and space switch roles. In this bizarre scenario, traveling forward in time would actually take you closer to the center of the black hole. And since you can't reverse direction in time, you'd be inexorably drawn towards the singularity, the black hole's infinitely dense core. However, it's important to note that all of this is purely theoretical. As of now, we have no way of testing these predictions. Black holes are incredibly far away, and their intense gravity makes them dangerous to approach. Even if we could send a probe into a black hole, it would be torn apart by the extreme gravitational forces before it could transmit any data back to us. In conclusion, while black holes may offer a potential route for time travel, they're not exactly practical, and there's still a lot we don't understand about them. So, for now, our time travel dreams will have to remain in the realm of science fiction. However, this is only a scenario proposed by scientists and cannot be verified because black holes are still too mysterious to humans. So, is time travel possible? Yes, but not in the way we often think. We've journeyed through a universe of ideas in this exploration, and it's time to round up our findings. Let's begin with Stephen Hawking's perspective. Despite his monumental contributions to the world of physics, he was quite skeptical about the idea of time travel as we often envision it. He argued that if time travel were possible, we would have already been visited by time travelers from the future. However, science does not entirely shun the concept of time manipulation. Albert Einstein's theory of special relativity presents time as a relative concept, moving slower or faster based on the observer's motion. This theory has been practically observed and proven, as seen in the case of the Kelly twins. Scott Kelly, who spent a significant amount of time aboard the International Space Station, aged slower than his Earth-bound twin, Mark. This is a form of time travel, albeit not the kind we're used to seeing in science fiction. Then we have the mysterious and enigmatic black holes. They are regions in space where gravity is so strong that nothing, not even light, can escape. Some theories suggest that within these black holes, time doesn't always move forward, hinting at a possibility of backward time travel. However, these are just theoretical speculations and cannot be confirmed due to the inaccessible and mysterious nature of black holes. So, where does this leave us? As it stands, time travel in its essence is possible. But it's not as simple as hopping into a time machine and dialing a date. It's more about finding a place where time moves slower relative to Earth. It's about bending and manipulating time, rather than breaking its flow. In conclusion, the concept of time travel is not as far-fetched as it may seem. While it might not align with the glamorous depictions in science fiction, it is a real phenomenon, grounded in the laws of physics. So next time you wish to time travel, remember, you might just need to find a place where time passes slower on Earth.